Okay, so today's topic, we're actually getting to our real topic this week, our official topic, if you will, is going to be NS3c, and that is I can multiply decimals. I can multiply decimals. So we're actually going to be multiplying decimals today. Now some of you go, oh man, decimals, and you start getting all stressed out and freaked out. It's going to be harder. It's not. There's a couple extra steps, and it's actually pretty easy. Okay? So the first things first is we need to take a look at a decimal number. So let's take a look at the number 324 and 798 thousandths. Okay? 234 and 798 thousandths. Okay? Now the thing we need to understand here is we need to take a look at these numbers. So I'm going to highlight the numbers on the left of the decimal, yellow, and I'm going to highlight the numbers on the right of the decimal, orange. Okay? Now, the numbers on the left, does anybody know what we call those numbers?
Whole numbers.
Erica?
Whole numbers.
Absolutely correct. Whole numbers. Those are called whole numbers because they are complete. Okay? Now, does anybody know what we call the numbers on the right? It's easier than you think. Erica? Part? Yeah. In this format, we call them decimals. Okay? You might hear them more formally referred to as decimal digits, because they are the digits in the decimal's place, meaning they are a part or a fraction. If you were to look at this number as just 798 thousandths, think about a 1,000-piece puzzle. You have 798 of them. Do you have a complete puzzle? So, again, over here, these are fractions, not wholes, decimals. Over here, these are your whole numbers. It's going to be important that you understand the distinction between those two. How many decimal digits do we have right here? Alexis?
3.
3, exactly. How many whole number digits do we have? Isaiah?
324.
Just the digit, not the actual number. Digits.
3, 2, 4.
Right, so we have 3 digits. 1, 2, 3. Okay? Good. Excellent. Okay, so that's going to be important. Okay, now let's actually look at an example. Okay? We have, let's look at 2 and 3/10 times 1 and 4/10. Okay? We're going to multiply that. And I'm going to show you how to do things 2 ways. I'm going to show you how to use the box method, if those of you who want to continue doing that, and I'm going to show you how to do it with the standard algorithm for those of you who prefer that. Okay, so let's take a look at this with the box method first. The first thing you're going to need to do is multiply as if it was a whole number. Okay? So for a minute, I want you to ignore the decimals. And mathematically, that's not really a math action we do. Ignore the decimals is not any kind of math. What you're actually doing is multiplying the 2 and 3/10 and the 1 and 4/10 by 10. And that makes them whole numbers. Okay? But that's a step that we can kind of do in our head. We don't need to really show that step. So just kind of think to yourself, you would do that automatically. So just look at them as whole numbers. And just know that the math behind it is you're multiplying them. But it's kind of one of those steps that it just becomes so automatic we don't really need to do it every time. So when we look at this, we're going to ignore the decimals for a minute. And we're going to see that as 23 times 14. Okay? And if we were to set that up in our box, okay, I'd have 20 and then the 3 and I'd have the 10 and then the 4. 23, 14. 10 and 4, 20 and 3. Okay? So far, nothing is new. We haven't done anything new. Okay? So, multiply as if it were a whole number. So, let's do 20 times 10 would be 200. 10 times 3, 20 times 4, 80. And 4 times 3 is 12. Okay? We're going to add them. 200 plus 80 plus 30 plus 12. We add those, and I get 12, carry the 1. 2 plus 1 is 3. So I get 322. So 23 times 14 equals 322. But we have to look at our original problem, and our original problem is decimals. So we can't just say, oh, 322 is the answer. We need to put the decimals back in there, and I'm going to show you how to do that, and it's actually very easy. First thing you need to do, count the number of decimal digits. Okay, count the number of decimal digits. Well, let's look here. 2 is a whole number. 3/10 is a decimal digit, right? That is a decimal digit. 1 is a whole number. 4/10 is your decimal digit. So how many decimal digits do I have there? 2. 2 decimal digits. Two decimal digits. Okay? 2 decimal digits. Keep that in the back of your mind. We'll go to step 3. Starting at the right, move the decimal to the left the number of decimal digits. Now that sounds more complicated than it really is. Okay? So let's take a look at this. Okay, so again we have 23 times 14 equals 322. So 2 and 3/10 times 1 and 4/10 equals, but we need to place those decimals back in there, and again we have 2 of them. Okay, so we start at the right where the decimal place is. If that's a whole number, the decimal is right here, and we move it to the left the number of decimal digits we had. And how many did we have? 2. So it goes 1, 2, and that is our answer. 3 and 22 hundredths. And that's all there is to it. Okay? I'm also going to show you another problem. So we'll look at, and let's look at a little bit more difficult one. Okay? Let's look at 3 and 31 hundredths times 23 hundredths. Now, you're going to see them place a 0 here a lot in front of the decimal. Okay? That is basically there so that the decimal point isn't overlooked. Because some people might look at that number and not realize there's a decimal there and say that it's 23. So they put the 0 there so that you can see, it draws your attention to the fact that there's a decimal there. Okay? But the 0 just means there's 0 whole numbers. Okay? So it's kind of one of those things, if you left out the 0, people would still understand what you meant. This is just more correct. Okay? It's kind of like capitalizing in English. If you don't capitalize a sentence, do people still understand what you mean?
Mm-hmm. Yeah.
But is capitalizing, that's just the way things are done to, it's the correct way to do it. Does that make sense?
Yep.
Okay. So let's take a look at this using the standard algorithm. Okay, so I have 3 and 31 hundredths but I'm going to think of that as 331. And then I have 23 hundredths. Okay? I'm going to multiply those. Okay? So I start with the 3. And I do 3 times 1 is 3. 3 times 9, or 3 times 3 is 9, sorry. 3 times 3 is 9. Then don't forget your 0 placeholder. Don't forget that, that's important. And remember, we kind of talked about before lunch where that came from. And that comes from the fact that we're moving over to the tens column. So we have that 0 placeholder in there to let us know we're moving over to that tens column. Okay? 2 times 1 is 2. 2 times 3 is 6. 2 times 3 is 6. Now I don't need to multiply that 0 through each of those because it's not going to change my number. 0 times any number is 0. So again, that's just there as kind of a placeholder too. So you don't need to do that one because it's on the, okay? 0 plus 3 is 3. 9, 10, 11. Carry the 1. 9 plus 1 is 10, plus the 16, carry the 1. 6 plus 1 is 7. So my answer is 7,613. Except for I have not added back my decimal yet. Remember, I ignored them at the beginning. I have to put them back. So how many do I have?
4.
Yes. 1 decimal digit, 2 decimal digits, 3, and 4 decimal digits. So I have 4 decimal digits. So starting from the right, I move it forward 1, 2, 3, 4, and there's my answer. So my answer to 3 and 31 hundredths multiplied by 23 hundredths equals 7,613 10,000ths. Okay? And that is how we do it. Questions?